It's no news that platform engineering teams these days are working to improve the developer experience when deploying cloud-native applications and using Kubernetes, while they work to provide the organization with a controlled and safe environment. On this video, we'll show you how Shipa and EKS together can help you achieve that. When talking to developers across many organizations, a constant and fair comment we hear a lot is that developers want to focus on delivering applications rather than spend time learning the intricacies of Kubernetes, how to create and manage the different objects, and so on. And this leads directly to an impact on the delivery speed and experience when delivering applications on Kubernetes. And this becomes an even more evident issue as teams scale their Kubernetes environments, leveraging multiple clusters, for example, which in turn introduce different objects, since these different clusters may be using different storage vendors, cluster versions, and others. When using EKS as your Kubernetes cluster provider, coupled with Shipa, this can easily be solved across platform engineering and development teams. When leveraging Shipa, platform engineers can create multiple landing pads, or pools, that are going to be pointing to multiple EKS clusters. These EKS clusters may have different cluster versions, different regions, and others, but Shipa makes it all agnostic, which allows the platform engineering team to focus on building the controls required by the business. Controls such as security scans required when applications are deployed, resource consumption limits, which services, such as databases, can applications deployed to this pool consume, volumes, and more. It's important to remember that all these rules will be automatically applied to applications as soon as they're deployed using that specific pool. Developers, on its turn, instead of creating Kubernetes objects and their related YAML files, instead of having to learn how Kubernetes works and spend time on infrastructure-related matters, they are now focused solely on deploying their application code. No Kubernetes objects whatsoever. They can place health checks, environment variables, and others that they understand should be executed when their applications are deployed and committed. Once this is done, Shipa will connect directly to the development workflow and CI/CD pipeline. So that way, no changes are introduced to the development workflow, but now, instead of the pipeline delivering the application directly to Kubernetes, which can be a point of failure and security vulnerabilities, it delivers to the predefined Shipa pools. Once delivered to the pool, Shipa will then validate permissions, perform security checks, attaches resource plans, and if it all passes the requirements based on the EKS cluster connected to that pool, Shipa then starts to automatically create all the objects for that application. This creates a cluster-agnostic environment, where your development team is only focused on delivering applications and your platform engineering team focuses on governance and controls, while Shipa and EKS will do the work for the application to be properly deployed and managed post-deployment. And this also brings a controlled state for your environment. So if anything is wrong, Shipa will roll back any changes made to your EKS cluster. Let's have a look at a live example. Let's have a look at what we have here. In front of us, we have our Shipa instance, and we have some information about how many nodes we have, number of pools, containers, and we can see the distribution of our clusters and its nodes. And we can see that we have EKS clusters distributed across different regions, some information about deployment, security scans that executed, and so on. But before we go into that, if we look at the clusters, for example, we can see that we have multiple Kubernetes clusters here that are coming from EKS. EKS 1, 2, and 3. And if we go into those clusters, for example, we can see that we have different pools set up for them, such as pool EKS 1, EKS 2, and 3. And they have different configurations such as the quota, the plan, and so on. And when we go into them, we can see the different locations they have. And inside each node, we can see metrics, units that are deployed, which basically relates directly to your applications and so on. So we can see that we have clusters distributed across different regions. Those are all EKS clusters. Those are clusters that are leveraging different versions These clusters are leveraging versions 1.14, 1.15, and 1.16. But for Shipa, you see that basically makes no difference. All the clusters are demonstrated the same way. We can see our applications that are deployed in here and others. Me as a platform engineer, what did I do in order to have that? I first created my pools. We can see an example of a pool here. The name of the pool is EKS3, for example, which is directly related to this pool here that we have. We can see that it's a Kubernetes pool, the name of the plan, which basically tells you how much memory and CPU your applications can consume, how many units your applications can have. So basically this tells you how much your applications can actually scale, if you want to perform security scans, and if you want to ignore any type of vulnerability, the teams that can have access, as well as the services that you want to attach to this pool. So we have one called Mongo EKS in here. And we can see this service directly here, Mongo EKS. You can create other type of services and you can point them to external services, such as if you create a Postgres, for example, you can enter the name, the host, the port, the users, and so on. And these services can be attached to your applications once deployed, so your applications can consume. We're going to show you an example of that. Okay, so great. So as a platform engineering team, we created the pools and we gave the pools access to the to the developers, which are basically our customers, and they can consume those with their applications. We already have a few applications deployed, but I'll show you an example. So just to keep in mind, we have pool EKS 1, 2, and 3, pointing to different clusters, different regions, and different cluster versions. Now me putting my development hat, I will deploy, I got access to the 3 pools, so I can see the pools here. Great. And me as a developer now, let me just clean up the environment. I have a very simple Go application. If we go into the main Go file, we have Shipa 4. We can change that and say Shipa on EKS, for example. We can save it. Inside Shipa YAML, I'm running an update in the system when the image is being built. And inside README, I have basically nothing. It's just a simple Go application. So here you can see that me as a developer, I haven't created any type of Kubernetes object. I don't need to understand how EKS works on the backend, how service meshes work on the backend, volumes, node port, cluster IP, deployment, stateful sets, and nothing of this. As a developer, I'm just concerned about creating my code, right? So great. So now that I have my code in here, I can say Shipa app create. I'll say EKS demo 1. It's a Go app. Should be owned by the team admin. And I want to deploy it on EKS 1. So I'm going to be pointing to my pool EKS 1, which is this pool here. Great, the application has been created. And it's important to also mention that the application can be created directly from the command line. So any developer or platform engineer can actually create the app directly from here, from the command line. Or if they desire, they can actually create their applications directly from Shipa's integration into CI/CD, such as on this example, where the CI, it's actually creating the application directly on Shipa and pointing to that pool. And same thing with the deployment process. The CI is doing the deployment process and will deploy to that app, which belongs to a certain pool. We can see here on Travis, another example of CI, which deploys and delivers my code directly to our different EKS clusters. But here I'll run a simple example directly from my command line. I have my code in front of me. I just want to ship it to Shipa and my EKS clusters. I'll just say git init. You can deploy it using git commands. So git init, git add, git commit, and then I'll do a git push to that repo that Shipa automatically creates for you, master. Great, the deployment will start, and what will happen here is Shipa will get your code and will build automatically the image for you, so you don't have to worry about building your Docker images and so on and so forth. Shipa will bundle it all into an image for you, and it will start the deployment on the cluster. Again, once all the checks have passed, as mentioned before, all the checks that have been established by the platform engineering team when the pool was created. And if all goes well, Shipa then communicates with the EKS cluster on the backend, and depending on the version and so on and so forth, Shipa creates the objects that are required for that app. Now, if you already have applications that are inside your Docker images, and they may be hosted on container registry in Amazon, or they may be on your Docker registry and so on and so forth, you can also deploy those directly into Shipa, and Shipa will validate your images. Again, the same thing, security scans, team, attached resources, and others, and we'll deploy that container image to the different EKS clusters you have. Great, the deployment is almost done. Great, deployment is complete and succeeded. If we go back to Shipa and we see EKS demo 1, we can go into the app if we want, ip.io. We can see Shipa on EKS. And if we go back to Shipa, we can see that we have here information about the application, environment variables. Soon enough, as soon as you start accessing the app, this will start generating information for your app. So information are going to be requests that you're receiving by minute, latency of your application, and so on. You can also start receiving in about 1 minute here data for your application or container consumption. You can see the units, where they are actually located, the life cycle. You can see the logs of exactly what happened, and as you keep deploying this application further, new versions, you can see the different logs, as well as you can roll back to any of the previous deployments. Security, if there are any scans, vulnerability that were found, and if you want to integrate that application into multiple incident management tools such as GitLab, VictorOps, OpsGenie, PagerDuty, and others. If any application security is found, for example, vulnerabilities are found, you can see here directly on security, it creates a scan date and deployment, and if you chose to ignore based on the pools, and you can see a detailed report for the ones that were found. If you have services attached to Shipa, like the Mongo EKS, for example, developers can come in here and say Mongo EKS 1. They can select a team if they own multiple teams, for example, or if they are part of multiple teams, and say create. It creates a database directly on Mongo, and from here they can bind that Mongo to any of the applications that they own. So with that, me as a developer, I didn't have to learn anything about my different EKS clusters. Shipa and EKS will figure out everything that needs to be done from my code all the way to deployment and then the application management. And as you can see, from the Shipa CLI, you have different options, such as you can scale your applications, you can see logs, you can access your app, you can roll back based on deployments, you can see security scans and others, as well as Shipa enable other components, such as canary deployment directly from your CI/CD and so on and so forth. So developers and platform engineering teams between Shipa and EKS, they have a complete environment across multiple clusters, multiple regions, multiple CI/CD tools, or if you have multiple incident tools, logging, monitoring, and others, Shipa and EKS together can become a key part and component of your development and delivery stack. Hope this was helpful. Thank you.